Question 9, again, long question, so I'm going to scan down through it and see what's happening. Heavy chain hangs freely, and under the effect of gravity, it forms, never even heard this word before, catenary, whatever. Using a suitable choice of coordinates, the equation of this catenary can be written as this. To demonstrate, a heavy chain is let hang freely between 2 points, P and Q, on opposite walls on level ground. The coordinates P and Q are minus 2k and 4l respectively, where k and l are constants. Both x and y are in meters. So we have our diagram. I'm just going to scan down to the question. Given that a point 0,2 lies on the chain, show that this is true. Okay, that maybe just sounds like basic subbing in, so we're just looking at functions to start off with. The only thing that's making me think, they're trying to do a leaving cert higher level question is that they have part of the function is missing and part of the function is an exponential. So that's not something you would have dealt with at junior cert or at ordinary level too much. Find the height of the chain above level ground when the x coordinate is 3. Well, when the x coordinate is 3, the height is the y coordinate. You know your output, so if that's 0, 2 here, you can see there the height is 2. Find k, the value of the y coordinate of p. So it sounds like functions. And maybe some algebra mixed in here as well in relation to my functions if I'm trying to show things work in a certain way. Show that R is the minimum point on the path. Well, now I think we're starting to get into a bit of calculus. Anytime we see maximum or minimum, you consider differentiation because of our turning points. And show that the slope of the tangent to the curve is always increasing. So slope, I'd definitely be considering my differentiation here. And then a little bit further down, okay, we see some integration. So it looks like a bit of a functions question that'll lead into some calculus later on. So they want me to, given that point 0,2 lies on the path of the chain, show that the value of A is 2. Well, if I have a point on the line, I might sub it in. And when I do that, when I have 2 for y and 0 for the x, then I end up with e to the power of 0 there and e to the power minus 0 there, and both of those are 1. So I end up with 2 is equal to a over 2. 1 plus 1 is 2. So I end up with that just a is 2, which is what they asked me to prove. So that's part 1 done. Part 2, find the height of the chain above level ground when the value of the x coordinate is 3. So when you know the x coordinate is 3, if you get the y coordinate, well then that's your height above ground. X is how far across, y is how high up. So again, I'm looking for the y coordinate is equal to a over 2. I know that's 2 over 2. E to the x over 2 plus e to the minus x over 2. And I now know that I'm in this particular part of the question, x is 3. And when I sub in for that, throw that into my calculator, I'll end up with y is equal to 4.7048 dot dot dot, and they just said to one decimal place, so 4.7 meters. That's part 2. Part 3. They asked me to find the value of k. So find k, the value of the y coordinate of p in terms of e. Now what have they told me about p? They've told me that minus 2 comma k is p. And I know that p is on the curve. You know, it's a point on the curve. So if I substitute in again, I end up with, so this is my y value, so y equals e to the x over 2. This is times a 1, 2 over 2 outside here, plus e to the minus x over 2. So k is equal to e to the minus 1 plus e to the power of 1, which is just k is equal to 1 over e plus e. So that is k in terms of e. So that's that part of the question done. And part 4. Okay, so we're going to use your answer in part 3 above to show that L, the value of the y coordinate of Q, is the same as, I'm going to try and show that L in this question is the same as k squared minus 2. Well, I know that Q is a point on the line and it contains L, so that's 4, 3 is on the line. Again, a point on the line, I'm going to sub it in. So I end up with L, because that's my y value, is equal to e to the power of 4 over 2 plus e to the power minus 4 over 2 times the 1 outside. Now I can not use that 1 anymore if I understand that 1 times anything is just the same thing. So L is equal to e to the power 2 plus 1 over e squared. So that's L. Now they want me to show that L is the same as k squared minus 2. Well, k I have in part 3, so this is where I'm going to use the previous part. So if k is equal to 1 all over e plus e, well, what about k squared? I can just square that. K squared is, take that to the side, work it out, you end up with e to the power 2 plus 1 all over e to the power 2 plus 2. So carefully square that out, multiply it by itself. That's k squared. And then if you want k squared minus 2, I'm just subtracting 2 from the k squared here. And that just gives me e to the power of x. Sorry, e to the power 2 plus 1 all over e to the power of 2, because I'm losing that 2 there, which is exactly the same as what I found out L to be. Here. So therefore L is equal to k squared minus 2. And that's all of part A done.